Welcome back. The current topic is Maxwell's equations, which are widely employed in electric fields and magnetic fields. Now, in the last class, we have discussed about displacement current and a displacement current density, and this is the expression which we have employed for determining the displacement current density. In today's class, we will discuss about the Maxwell's equations, the four Maxwell's equations which are widely employed in electromagnetic fields. These were put together by Maxwell and they help us in determining the magnetic fields and also electric fields. And we do have two forms, integral forms and also differential forms for these Maxwell's equations. Okay, so all the major laws of electromagnetism which we have discussed in our 4 units, they will be brought together now. See, the first equation, Maxwell's first equation, you ignore the number because they will be appearing in random fashion. The first thing is Gauss law. We have seen already Gauss law. Q is equal to surface integral of electric flux density vector, which is also equal to volume integral of charge density. Right. The differential form of this one, we have converted this one using Laplace theorem. This was dou dot D, divergence of D is equal to rho. This was the first law, Gauss law, which we have seen in electric fields. And in electric fields itself, we have seen another equation. I think it is not there. The next one is non-existence of isolated magnetic charge, which means we have seen that surface integral of B dot ds is equal to 0. So, which is nothing but, if I apply again divergence theorem, this will become del dot B dot dV, divergence of B dV over the volume integral. This will become 0. So, which means that del dot B is equal to 0. Divergence of B is 0, whereas divergence of D is rho, charge density, volume charge density. And next is Faraday's law. We have seen in the previous week itself that the EMF which is induced is equal to the rate of change of flux density. So we have seen this expression, we have modified that one. So del cross E is equal to minus dou P by dou T. And also the Ampere circuit law, which we have already done. For Ampere circuit law, earlier we have done only this one. Now we have included this displacement current also. So del cross H is equal to J plus dou D by dou T. So these are the expressions, 2 on divergence and 2 on curl of. So these are divergence of flux densities, whereas these are curls of field intensity vectors. Now these equations can be modified for static fields. In static fields, which means that dou B by dou T, B and D both are constant with respect to time. So this will become 0 and this will become 0. So you will get only del cross H is equal to J. This is we have done in unit number 3. And here also del cross E is equal to 0, which we have tried in unit number 2. Okay. So for static fields, only changes, the fields will be constant with respect to time. So that's why you have got this change here and here. The rest of the equations are same. So what is the significance of these equations? The first law, which is nothing but Gauss law, it states that the total electric displacement flux passing through a closed surface is equal to the total charge which is enclosed by that surface. Isn't it? This is the first law. The second law, which discusses about convergence of magnetic fields, or we can write it as del dot B is equal to 0, which means that the total magnetic flux passing through any closed surface is always equal to 0. So the third law states that electromotive force around a closed path is equal to inflow of magnetic current through any surface bounded by that path. del cross E, del cross E is equal to minus 25 root. And the last equation, which is the Ampere circuit law modified one, del cross H is equal to J, and if at all there is another equation, it is dou V by dot. Sorry, I think it is dou D by dot. Right. It was, yeah. Right, these are the Maxwell's equations. We employ these equations to determine the magnetic field intensity or electric field intensity when other vectors have been given for us. Okay, so I hope that now you are able to state Maxwell's equations for both time varying fields and also static fields. Okay, we'll solve the problems, simple problems in the class. Thank you.